Hi everyone, in this lesson we're going to look at, this is the last time we'll be looking at parabolas. We'll be looking at some other graphs later on, and yeah, so this is it. And we're going to be looking at finding the intersection of a line and a parabola. I'll show you how to do it by hand and also how to do it with your CAS. And also determine how many points of intersection there are, which we'll go through. All right, so let's get started. We can see here that we're asked to find any points of intersection. Now, before we do that, let me show you in your CAS, if I was to sketch the equation, see this thing here, x squared minus 3x. Let's go ahead, x squared minus 3x, if I sketch that. And then I want to sketch the graph of y is equal to 4. So I can press the tab button. And just remember, in your test, you're going to be able to use your CAS calculator for this unit. If I have y is equal to 4, then you can see there that it's going to intersect at 2 spots. Now, of course, if you've got your calculator in your test, sure, you can show us how to do it, but you can also use your technology as well. You're going to need that in year 11 and 12 menu. Let's go to Analyze Graph. And what we want is the intersection, and then what will come up is this thing. Now you can use your CAS like a mouse, and you can just scroll to the left or right. I'm going to press down, so by pressing on this button here, you can then select that, and as you can see, there's one of our solutions. So we want to find that solution, so we've done it in the CAS, and of course we want to find the other one. So we want to analyze the graph again, and we want to go to intersection. So I want you to practice this as we go. Okay, as you can see, there's my two solutions. I've got the coordinate 4, 4, so at intersection it would make sense that both the y coordinate is 4 because it's the line y equals 4, and this one here is another one. Okay, so that's graphically what we're trying to find. We're trying to find those 2 points. So how do we do this by hand? Well, you can see that both of those points share the same y coordinate. They also share the x, but you can see that we've got both of these equations share the same y where they intersect. So we've got one equation there, and we've also got the other one, which is y equals 4. So as you can see, what we're going to do is if they both share the y, then we can sort of let those equations equal each other. And what we have is we want to solve this equation here. Now, how do we do that? Well, first of all, let's get everything on one side, and let's see if we can factorize. Let's subtract 4 from both sides, which gives us x squared take 3x minus 4. And of course, if we can factorize, we always do. Is there two numbers that multiply to give minus 4 and add to give minus 3? Well, there is. It's x minus 4. And x plus 1, okay, because of course minus 4 times 1 is minus 4, and minus 4 plus 1 is equal to minus 3. All right, so now we know using the null factor law that gives me two solutions. X would be equal to, well, x would be equal to 4, or x is also equal to -1. All right, so now that we've found that, we can go ahead and substitute in the equation. But as we know, it's the line y equals 4 which is intersecting. So it's probably fair to say that they're both going to have the coordinates. So the intersection, which is what we found on the CAS calculator too, by the way, is we've got -1, 4, and we've also got 4 and 4. Okay, let's try this other one. Let's do it by hand. You can do it. We can do it by the CAS as well. But what we want is we know that these two equations both share the same y coordinate. So that means that x squared plus 2x plus 4 has to be equal to -2. Let's subtract 2 from both sides. X squared plus 2x plus 2 is there two things, though, that multiply to give 2 and add to give 2? I don't think there is. So we're going to have to, we can't factorise, so we'll have to solve this. We could do it a couple of ways. We could complete the square, or we could go ahead and use the quadratic equation. All right, so let's use the quadratic equation. The coefficient of x squared is 1. The coefficient of x is 2. And the constant is 2, which means that if I was to do this, I can find that solution by using the quadratic equation. Minus b plus or minus b squared, which is 2 squared, minus 4ac. Minus 4, this is going to be a problem. 4 times 1 times 2. Now, the thing is that it says find any points of intersection. What do you notice when you get this? Well, I get this. I'm trying to do the square root of 4 take away 8, and that's, of course, a negative number. We can't, there's no solution there. Let's see if we can sketch it on the CAS and sort of have a look. So we've got the graph. Let's have a look. We've got x squared plus 2x plus x squared plus 2x plus 4. Actually, yep, that's right. So x squared plus 2x plus 4. Let's sketch that. So let's show why we're having issues. Well, first of all, that is a graph which has a turning point there, clearly above the x-axis. If I go ahead and press tab and I go to y equals minus 2, then as you can see, there is no point of intersection. So I guess this one, find any points of intersection? Well, there is no intersection. Okay, so, and we'll get into another reason why this has to do with this discriminant here. When I go ahead and find this, later on we're going to look that the discriminant would actually be equal to, in this case, b squared minus 4ac, which we just found is 4 take away 8, which is negative 4. So therefore, there's no solutions. Okay. Now, so this is where I sort of, in your notes, you can see there, it talks about the discriminant. So if there's no solutions, then that means that your discriminant is going to be less than 0. So if you go ahead and you can't solve it, that's okay. It could be no solutions. If it just touches there just the once, there's only going to be one solution, which means your discriminant will be 0. And if the discriminant is greater than 0, you're going to have 2 solutions. So it could be a line which cuts a parabola in 2 places. Okay, so now let's have a look, and we'll do some more. I'll get you to try this. I might do the first one. All right, so once again, we want y is equal to x squared take x, and y is equal to 2, and we want them to equal. Okay, so we want to find where they equal. Well, they equal when they both have the same y coordinates. So we've got to let one equation equal the other, or we can say that the right-hand side of this first one is equal to the right-hand side of the second one. Now let's solve it. Let's subtract 2 from both sides, and that's going to give us x squared take x take 2 is equal to 0. Can we factorise that? Is there 2 numbers which multiply to give negative 2 and add to give negative 1? You betcha we're looking at negative 2 times 1 and negative 2 plus 1. Okay, so there's, let's do that. X minus 2, x plus 1 is equal to 0. So what does x have to be? Using the null factor law, it would have to be equal 2, and x would also have to equal negative 1. Now, you're going to be quite fortunate in that we'll probably ask you something like this, but you have the aid of the CAS calculator. So let's show you how to do it again. Let's go to a new graph. Let's go to a new document altogether. And we're going to put in x squared take x. So put that in. So you really need to be practicing your CAS calculator. All right. There's x squared take x, and then we've got y is equal to 2. You can see there that there's 2 intersections. And if we go to menu, analyze graph, intersection, practice, choosing to the left of the point and selecting, and then dragging it across and selecting again. You can see there's one of our solutions. And if I was to do the same thing again, there you go. So look, we knew that y is equal to 2 because this line is all of the y values equal to 2. So that's no surprise. And as you can see, here's our two x values, -1 and 2, which is we've got here. So the points of intersection are at intersection. They intersect at, well, give us the coordinates. We've got -1, 2, and also 2, 2. Handy to do it by hand, especially sort of if you're going on to methods next year. You won't have to do any of this stuff if you're going on to do general maths next year. Let's do this last one. So this time, let's just, the right-hand side of the first equation is equal to the right-hand side of the next. And let's go ahead and solve this. X squared plus 4x. Let's add 4 to both sides, plus 5. This time, though, it looks as though, can we do this by, can we factorize? Well, is there two numbers which multiply to give 5 and add to give 4? I certainly can't think of those. So we can't factorize. One thing what we could do, though, is now that we've got this value here, let's see if we can solve this equation, because like we said before, if we look up here, if there's the discriminant, if we go ahead and find the discriminant and we have it's less than 0, then there's no solution. So we can just stop there. So I want you to get in the habit of doing that. It's always going to be a good thing. If you can factorize, of course, then it's probably fair to say that there are. So let's do that. The discriminant is b squared minus 4ac, and of course b squared, b is 4, so that's 4 squared, minus 4 times a, which is the coefficient of x squared, times c, which is 16 take away 20, which is -4. So that means that there are no solutions. How can you possibly, if I was to do the quadratic equation and I wanted to take the square root of b squared minus 4ac, as you can see that we can't get the square root of a negative number. So that's why, if that value is less than 0, there's no solutions. All right, now let's see if we can do this one. Now, of course, some of these, look, for the most part, will probably give you fairly straightforward ones if you were to do it by hand, but also keep in mind that we'll probably just require you to be able to use a calculator. Let's do it by hand, and let's do this first one by hand. So we've got y is equal to x squared, and they both share the same y. Now let's look at, if I was to, we know what the graph of x squared looks like. That goes through the origin, and it looks something like this. This is the graph of y equals x squared. And the graph of 2x will go sort of through the origin, and it'll go through something like that. Okay, so we know that there's going to be two solutions. Just by looking at that, there's going to be one solution. We're going to have to find this value over here. Okay, so let's do that. Where does y equal x squared and y equal 2x intersect? Well, let's let them equal. Means that these y values are going to be the same. So let's use the right-hand side of the equation. X squared is equal to 2x. Now, you could do this a couple of ways. We could factorize. So let's try this. Let's try method 1. Let's try method 1, which is to factorize. And let's take the 2x over to the other side, and that's equal to 0. What's the highest common factor? X, like so. And what does that mean? Well, x is equal to 0. Would be one of my solutions, and the other one would be x is equal to 2. Okay, now, of course, now that we've done that, we've found that by hand, we can sub that into any of the equation. When x equals 0, y is equal to 0 as well. And when x equals 2, Well, 2 squared is equal to 4, or 2 times 2 is also equal to 4. So therefore, y is equal to 4 is the other solution. So where do they intersect? It's 0, 0, and also 2, 4. Now, method 2, if I was to get this, x squared is equal to 2x, well, what we could do is we could divide both sides by x. If I do x squared divided by x, that's going to give me x. Okay, and of course, if I do that, that's going to give me x is equal to 2. Problem is though, if I do that, I'm sort of cancelling out a solution. So it'll find this one for me, but I'm not going to be able to find this one. What I'm going to suggest is, if you do this, you want to be factorising. Okay, a lot of you will probably try to do that, but you're sort of going to eliminate one of your solutions by dividing by x. Okay, so you're better off doing it this way. This was going to show that there's 2 solutions. Of course, we could do that in the calculator as well, which you can practice. Now, let's see this one. We might even do this one in a calculator. So I've got the y is equal to minus 4x squared minus x plus 6. And the other one is y is equal to 3x plus 7. First of all, let's sketch this in a calculator, and let's see if we can do it. I think that's probably the most important thing. So let's go ahead and do it. We've got to get good with our calculator. Minus 4x squared minus x, and what was it, plus 6. And then we've got the graph of 3x plus 7. So we're going to press the tab key, 3x plus 7. So we can see, well, look at that. That's looking like, if I zoom in a little bit, if I zoom in, that looks like it only touches it at 1 point. That's interesting. Well, I'll sort of talk about that. Keep that a mental note of that, because if we do it by hand, we should be able to hopefully show you why that's the case. All right, so the right-hand sides of the equation, let's let them equal, because they both share the same y value. Now, let's that's right. So let's do this. Let's subtract 3x from both sides. So I've got negative 7x squared minus x minus 3x is minus 4x. And of course, if I want to subtract 7 from the right-hand side, that's going to give me 6 plus minus 7 is minus 1. Okay, the idea is you want to get everything on the one side. Now, admittedly, this particular one here is a non-monic polynomial, trinomial, and you can see that for the most part, we probably would do ones which were easier. So I probably would revert, if you get something like this, I probably would ask you, if you can't factorise for the time being, and you can't complete the square, then we could probably go straight to the quadratic equation. Okay, I wouldn't sort of expect you to factorise any of this. Now, as it turns out, let's use the quadratic equation. Now, we saw that there's going to be one solution. Well, how can we find that? Well, let's find the discriminant first. B squared minus 4ac. Okay, where a is the coefficient of x squared, so a is equal to negative 7. B is equal to negative 4, and C is the constant, which is negative 1. If I go ahead and throw that in, let's see what we get. B squared is minus 4 squared, minus 4 times A times C. All right, I can see what I've done wrong there for a second. I don't know how minus 4x squared become minus 7. So let me just change that up. That's minus 4. Let's try that again. A is negative 4. And let's see if we can, because I was looking at it and saying, well, something didn't add up there. B squared is minus 4 squared. Minus 4 times A is minus 4 times C, which is minus 1. Okay, now that's going to be, negative 4 squared is 16. And then we've got, this is going to be positive 4 times negative 4 is minus 16. Look at that, the discriminant is equal to 0 like it should be. Because if the discriminant is equal to 0, then that means that there is one solution. So we've got to find that one solution. All right, so now, look, I might as well use the quadratic equation. We've gone through, what is that one solution? Well, let's use the quadratic equation. Minus b, which is minus 4, plus or minus b squared minus 4ac. Well, we've already found that. It's the square root of 0. Okay, so we'll just leave it like that, and 2a is minus 2 times minus 4, which is minus 8. Okay, so this isn't going to be so bad. We're looking at the value of 4. The top is a negative times a negative is a positive. The square root of 0, we don't have to worry about that because it's just 0. And as you can see, that's going to be 4 over minus 8, which is minus a half. Now, we can, when x equals minus a half, we can throw that into either one of those equations. But as you can see, if I can, and you can do that yourself, but if I was to find that and do the intersection, then you can see there, that gives me, if I just grab this one here, you can see that there's my coordinate there. There's one intersection, and that's at negative a half, and as it turns out, 5.5, or if you did that as a fraction, 11 over 2. All right, so this will be the last chance you sort of get to use the quadratic equation. We won't have to sort of see it anymore, obviously, in your exam. We'll have to do all of that sort of stuff again. So, as you can see, a little bit involved. You'll need to let the equations equal each other, rearrange, use the discriminant to find out if there's solutions. There's one solution, and go ahead and find that. Look, as it turns out, we could probably factorize this as well, but if you want to use the quadratic equation, that's perfectly fine. Okay, now, this time we're looking at ones where you have to, it says determine the number of solutions. Well, I'm going to show you these ones just quickly, and then I'll get you to try the last couple. All right, so as you can see, once again, we're trying to find the number of solutions, but what we have to do is we need to have those right-hand sides of the equations, and they need to equal each other. So we need to solve this. Let's get everything to one side. We're going to subtract x. If you like, we'll do that first. X squared plus 2x minus 1 is equal to minus 2. Then we want to add 2 to both sides. Get it over the other side. And that gives us x squared plus 2x. Plus 2 is plus 1. Now, it says determine the number of solutions. We're not even asking you to find the intersection. So how do we find how many solutions there are for this? Well, I guess you could use the discriminant if you like, which you can do, or we could actually just go ahead and find it. Why not? I've got two numbers which multiply to give 1 and add to give 2. Well, that's 1 and 1. Okay, thing is though, is that if I factorize that, we've actually got a repeated solution. Okay, x plus 1 and x plus 1. Well, that's the same as x plus 1 all squared is equal to 0. How many solutions do I have? Well, I've just got the 1. X is equal to minus 1 would be one solution. And of course, that would come up with a y coordinate. How would I do that? How without factorizing? Well, I could use the discriminant. The discriminant is equal to b squared minus 4ac. And b squared is, so 2 squared minus 4 times 1 times 1, which is 4 take away 4, which of course is 0. So that's how I get one solution. Let's try the other one now. We're going to get 2x squared minus 3x plus 8 is equal to the right-hand side, which is 5 take 2x. Let's add 2x to both sides. So we want to get everything on one side. 2x squared, take away x. Minus 3x plus 2x is minus x. 8 take away 5 is 3. So I want to get that. Well, this time we could solve it in our CAS, or we could just use, if we want to do it by hand, and we've just been asked to find how many solutions there are. So let's use the discriminant. Okay, the discriminant is equal to b squared minus 4ac, which is b is minus 1. So it's minus 1 squared minus 4 times 2 times 3. So as you can see, that it looking to me as though that's 1, and what's that? 6 times 4 is minus, so we've got minus 24. The discriminant is minus 23. What does that equal? Well, you can have a look up here. What is that? We're going to have to remind ourselves that if it's less than 0, there are 0 solutions, which means that there's no intersection at all. Okay, and I'm going to show you one last time. So there's no intersection. If I sketch that in my CAS calculator, you should be able to see that they don't intersect anymore. Let's have a look. 2x squared. All right, got this graph here. Want to get rid of it. Let's go to the home screen and go to a new document. No, we don't want to save it. Let's go to the new graph, and let's put in our 2x squared minus 3x. Plus 8. All right, it's hidden there, it was sort of there. So there's our graph of 2x squared minus 3x plus 8. Now we want to let's get out of that. Let's press the tab button and let's add another graph, which is 5 take away 2x. Okay, as you can see, if I scroll in, I can Windows zoom in, they don't touch, so therefore there's no solutions. All right, now, look, I'm going to pause this. I'll get you to pause this. I'd like you to try these now. Okay, see if you can do these, determine the points of intersection. Probably a pretty common thing we would ask in an exam 1 question, which you could do without a calculator. So you're going to need to know how to do this somewhat without a calculator. Of course, in your test, though, you will have one. So give this a go. Pause it now and give it a go. All right, so hopefully you have tried this now. In the left-hand side, this one, let them equal. Then let's get everything on one side. So I want to add 1 to both sides, and I want to subtract x from both sides. Once you do that, we can then use the discriminant to work out whether we can, so if we're asked to find an intersection, we'd go ahead and find it, but would we need to if there's no solutions? Obviously not. So in this case, the first step is use that discriminant. In this case, I've got the discriminant is 6 squared minus 4 times 1 times minus 3. That becomes 12 plus 36 is 48. So as you can see, the discriminant is greater than 0. So there are 2 solutions. And likewise with this one, this time we want to add 2x to both sides. We also want to subtract 5, and then that gives us this thing here. Now, when I go ahead and find the discriminant there, I get a negative number, negative 11, which means that there are no solutions, so that hence there's no intersection. Like I said, you should try this on your CAS calculator. You've got the instructions there. Put the graphs in, menu, analyze graph, intersection. Try practicing finding those as well, because that's where you're going to be able to use your CAS in your test. So please practice those skills. All right, so hopefully you can now try some of these questions. We'll see you in class, and good luck.